This is worksheet 17 problem 1E, and this counter we see is similar to the counter we had in 1D. It makes an 8-bit counter out of two 4-bit counters. So we can redraw this in a way that's a little easier for us to look at, because we know the effect is to make an 8-bit counter. So we'll have outputs Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7, inputs D0, D1, D2, D3, D4, D5, D6, D7. We'll have a load, and we'll have the clock, and we'll have an enable. So we can draw the two 4-bit counters connected together as this one 8-bit counter. Now we do need to pay attention to what's being loaded. What's being loaded is, so enable for the first counter is 1, so that's going to mean our entire 8-bit counter is enabled. We have 1, 0, 1, 0, and then these values are all 0. We don't worry about this second enable because that's being taken care of with the action here. So this whole group of two counters will act like an 8-bit counter with just one enable and one load. And we have on our 8-bit counter, we don't have to draw this part because this part is just what's making it be an 8-bit counter. But we do have to worry about this part right here because that's telling it when to load. So when you have an AND of Q3 and Q4, then it's going to load. So if we have an AND of Q3 and Q4, then that's going to load, and of course we have the clock here. So now that we've simplified it to look like this, then it's pretty easy to see what happens based on what we did with the earlier problems, the earlier parts of problem 1. It's going to count upward until it reaches a point where both Q3 and Q4 are 1. So let's see when Q3 and Q4 would both be 1. That would be 1, 1, 0, 0, 0. So that would be when you had this represents the 16's place, this represents the 8's place. So when both 16 and 8 are 1, and 16 plus 8 is 24. So it's going to count until it gets to 24, and then it's going to load. And what it's going to load is this value, which is 0, 0, 0, 0, 1, 0, 0, 1, 0, 1, which is 5. So if we start from any value from 0 to 24, it will count up to 24. So 0, 1, 2, up to 24, and then it'll 24. Then it'll load 5, 6, 7, and it'll count up to 24. And then it'll load 5, and it'll count up to 24, and so on. If you happen to start with any number that's not between 0 and 24, then what's going to happen is it will count up until the next time that both Q3 and Q1 are equal to 0. So if you had something like 0, 1, 0, 0, 0, 1, 0, 0. So let's see what value I've done here. This is the 1's place, the 2's place, the 4's place, 8, 16, 32, 64. So this value is 68. But it does not have both Q3, so this is Q0, Q1, Q2, Q3, Q4, does not have both Q3 and Q4 equal to 1, and so it will continue counting until the next time that Q3 and Q4 equal to 1. And the next time it will get to a spot where both Q3 and Q4 are equal to 1 will be at 0, 1, 0, 1, 1, 0, 0, 0. So it would count from 68 to this number. Now let's see what this number is. This is the 8's place, the 16's place, the 64's place. So that's 64 plus 16 plus 8. It's 18, carry the 1 is 88. So it'll count from 68 to 88, 68, 69, 60, 10, 70, 71, and so forth until we get to 88. And then when we get to 88, it'll load, and it'll load a 5. It'll load 5, and then 6, and then up to 24, and then 5, 6, and up to 24. And so no matter where you start, eventually you'll get to a spot where both Q3 and Q4 are equal to 1, at which point it'll load a 5, and then it'll count to 24, and then 5, and then 24, and then 5, and then 24. So the steady state count is 5 to 24, and 5 to 24.